Hello, in this video we are going to learn about simple interest and compound interest. So let us first look at simple interest. Simple interest. Now I am going to present this simple interest phenomena using an example. Let's say John, so here is my example. Let's say John took a loan of $10,000 from a bank. So he took a loan. So John took a loan from a bank. Okay, so about $10,000. So this is called principal P. Okay, so principal amount, principal P is $10,000. Okay, so that is the money he took as a loan from the bank. Now bank told him that loan is for an interest of 10% interest. Okay, so interest rate, and it is going to express using a symbol R. So interest rate is 10%. Now whenever the interest rate is presented in a percentage, we always have to express interest rate using a decimal value. So what is the decimal? It will be 0.10. Okay, so that's the annual interest rate. Now so after 5 years we want to know how much money John have to pay back. Okay, first of all let's find out. So after 5 years, so that means T, that means time T equals 5 years. All right, and we want to find what the amount of interest he have to pay back. Okay, so interest he have to pay back I, that's the value we need to find. So let's do some little math on this side. Okay, so as he took a loan of $10,000 at an annual interest rate of 10%, after 1 year what is going to be the interest? 10% of $10,000 is actually $1,000. So that is interest for 1 year. What will be the interest for 2 years? We know that it will be $2,000, and for 3 years it will be $3,000. For 4 years it will be $4,000. For 5 years it is $5,000. Okay, that's the interest. So now see how I basically calculated that interest I. So how I calculated this value? I is equal PRT. Okay, so what is I? I is interest after T year, and P is the principal value, R is the annual interest rate, and T is the time in year. So let's so if I put all these value, so what is my I? My I become P is 10,000 multiplied by R is 0.10. R is my 0.10 in expressed in decimal, and T is 5 year. So if you punch in the calculator, you are going to find that is $5,000. Okay, so that is the amount of interest you have to pay back after 5 years. Okay, and you can see that is the exactly same amount we got here. Okay, so this is the interest, and that is called simple interest. All right, now what is the total amount of money he have to pay back after 5 years? The total amount of money. So if I use another symbol, so let's say total amount of money. So amount after T year if I express it using a symbol A, what is my A? A is the principal plus the interest. All right, so that is the definition of the amount after T year. That's the money he have to pay back. So now for this particular problem, what is the amount of money John have to pay back? So A is what? P plus I, and P is $10,000 and I is $5,000. So the total amount of money he have to pay back is $15,000. So that is the amount you have to pay back after 5 years to the bank. So as you can see, even though he borrowed only $10,000 from the bank, after 5 years with the simple interest calculation, we found that he have to pay back $15,000. So it's quite a lots of money, right? Now so this is simply a simple interest. Now let's see what is compound interest. All right, so let's see the compound interest. Now previously you have seen after 1 year his interest was $1,000. Okay, so let's do this math again. Okay, just very so his P is $10,000 principal at a rate of what? R is 10%. Okay, so I am going to compound the interest yearly. Okay, so after 1 year, what is the interest I? Interest I is going to be $1,000. Okay, as you can see from here. Now what is going to be the total amount after 1 year? It will be 10,000 plus this interest, so it will be $11,000. Now in the second year, when you are going to calculate the I, that time we cannot use this P. Remember, in this equation I have used the same P. I have used the same P for the simple interest, but for this case I have to use this new amount. Okay, so what is going to be the interest? 10% interest for a amount $11,000. So interest will be basically $1,100. So what will be the total amount then? So 11,000 plus 1,100. So it will be basically $12,100. Okay, now for the third year, when we are going to calculate I, we are going to use this new P. Okay, and then so on and so forth. Now as you can see here, I am compound the interest after every year. So this is called annual compound interest. So you can see the interest is going higher and higher, and it will be much higher than this. So let me write down. So if I basically put all this calculation in a formula, so the formula will be A equals P1 plus R over N power NT. Okay, so this is the formula for compound interest. Okay, now in this case we know what is P, we know what is R, we know what is T. Only thing is what is N. So N is, so the definition of N is number of time interest is compounded. So number of times interest is compounded. Interest is compounded. So for example, let's say if my interest is compounded yearly, so for yearly, So if my interest is compounded yearly, then n will be 1. If my interest is compounded quarterly, so if my interest is quarterly, then n is going to be 4. So that means my interest is compounded 4 times in a year. Now if interest is compounded monthly, then my n will be 12, because my interest is compounded 12 times in a year. And if my interest is compounded daily, then n will be 365. Okay, so this is basically the compound interest formula. So now what I am going to do is I am going to solve the same problem using the compound interest formula, so that I can try to basically compare the result with the simple interest. So let's see. So what I want, so the same problem, so with same problem, that means my P is $10,000, my R is 10%, which is 0.10, and my T is 5 year. And what I want to find the value, that means the amount of money John have to pay back if interest is compounded yearly. So if interest is compounded yearly, I need to find how much money John have to pay back. So what is the amount of money he have to pay back? A. So I need to find out how much money John have to pay back if interest is compounded quarterly. So I need to find A, and I need to find how much John have to pay back if interest is compounded monthly. So I need to find also A, and also I need to find out how much money John have to pay back if interest is compounded daily. And same, I have to find A. Just to remind you, or I already know that for yearly n is equal to 1, for quarterly n equal to 4, for monthly n equals 12, and for daily n equals 365. So let's try to find out the value of A. What is the definition of A? A is P multiplied by 1 plus R over N NT. So let me simply write down the equation just for one time. P1 plus R over N power NT. So let's see, P is my 10,000. 10,000 multiplied by 1 plus, what is my R? R is 0.10. And what is my N? For this case is 1. And NT, so N is 1 multiplied by T is 5. If you punch the calculator, you are going to find that John have to pay back $16,105. So let's do the math for quarterly. So for quarterly, what is going to be my A? 10,000 multiplied by 1 plus R is same 0.10, and N is this time 4, power N is 4, and multiplied by 5. If you do the math, you are going to find John have to pay back $16,386. All right, so let's see how much he have to pay if interest is compounded monthly. For monthly, of course it is P is 10,000, then 1 plus, that's the same thing, but this time N is 12, power 12 multiplied by 5. So I found, after punching the calculator, it is $16,453. All right, so finally if interest is compounded daily, so my P is same 10,000, 1 plus R is same, this time my N is 365 power 365 multiplied by 12, and if I punch the calculator, I found it is 16,486. Okay, now let's pause for a moment and let's see. When we are calculating the interest, that how much money John have to pay back after 5 years, for simple interest we found it is $15,000 straight. Okay, with simple interest calculation. Now if interest is compounded, and if interest is compounded yearly, then John have to pay $16,105. So as you can see, it is a big jump. Okay, now if interest is compounded quarterly, he have to pay back even more money. If interest is compounded monthly, he have to pay back even more money, and if interest is compounded daily, he have to pay back even more money. All right, so as you can see, our banks, they actually calculate not only daily but continuously, which is more than daily, and that is the formula I'm going to show you a little later. So let us see what is the continuous compound interest. Okay, so before I present you to continuous compound interest, first of all I'm going to introduce you a term called E. So let us see what is the definition of E. So definition of E, which is basically Euler number. Euler number. All right, so what is the definition of Euler number? So it says that that 1 plus 1 over h power h. Okay, if this if h is going larger and larger, so if h is going larger and larger, then this term basically approach to a constant number, and that number is called E. So let's so what is the definition of E? So E is basically, in a classical mathematical definition, limit h tends to a larger number, for which one? 1 plus 1 over h power h. Okay, so let's do a little math. So if h is equal to 20, okay, so what is the let's evaluate this expression. So if I evaluate this expression, it will be 1 plus 1 over h, which is 20 power 20, and I found that number to be 2.65. Okay, so if h is 100, so what will be the value? 1 over h, which is 100, power h, which is 100, which will be equal to 2.705. So you do not have to go to put h equal to infinite, like h equal to 10,000, 20,000. It is not necessary. If you put, you are going to find that this limiting value of E become, this is basically 2.71828 and even more number, and I don't want to write all, so just you can remember only these few decimals. So E is 2.71812. Now so a little while ago you saw what? If my interest is compounded, this is the formula I have used. Now we saw if interest is compounded yearly, if interest is compounded quarterly, if interest is compounded monthly, if interest compounded daily, then we are able to calculate the values. Now what about if interest is compounded continuously? So if interest is compounded continuously, if interest is compounded continuously, then the formula will be A equals P e power RT. Okay, so this is the formula for continuous compound interest. All right, so now let's solve the exactly same problem. Okay, let me see how much John have to pay back. So P is 10,000 as before, and E is E, and then R is what? R is 0.10 and T is 5. And when I punch my calculator, I found that value to be 16,487. So as you can see that the amount of money John have to pay back when the bank calculate with interest, continuous compound interest, it is even more than daily compound interest. And this is the way the bank actually calculate the interest. So as you can see, actually bank actually get lots of money from you guys. In this particular example, I actually took only P equal to $10,000. Okay, and T is only for 5 years. Now think about it. When you are taking a mortgage for your home, let's say your home mortgage is $150,000. So if your P will be 150,000 and T will be around what? You take sometimes loan for 20-year mortgage or 30-year mortgage. So T will be 20 or 30. In that case, your A will be much larger. Okay, so you can do that math at your home, and you're going to find you are paying a lots of money to the bank. So in my opinion, it is not a good idea to take mortgage loan. So if you can buy cash, that would be better. Okay, all right, thank you, see you in the next